Okay, lastly we're going to talk about the trig identities, which you'll see more and more of these as we move on to chapter 7, but these are the most basic ones that we're going to talk about in this chapter. These identities are just basically equations that you can use and manipulate to solve for x in certain cases. One equation is sine squared theta plus cosine squared theta equals 1. Basically that means whenever you have an angle, theta, or r or t, or whatever your angle is called, the sine of that angle squared plus cosine of that angle squared is always going to be equal to 1. Another identity, tan squared theta, tangent squared theta plus 1 is secant squared theta. And then 1 plus cotangent squared theta is equal to cosecant squared theta. What you're going to do is use these to solve for t or theta or whatever you may need, depending on what your question is. So, for example, if you're asked to write the tangent of t in terms of sine t, where t is in quadrant 4, what you need to do is figure out how you can manipulate one of these trig functions to write tangent t. Now, first thing we have to remember is we know that tangent t is the same thing as sine t over cosine t, right? Sorry, that doesn't look like cosine. Cosine t. So we know that tangent is sine over cosine. So if we can use one of these trig functions that have sine and cosine in them and manipulate that trig function, we can solve for tan t. Do you see if we use the trig function sine squared plus cosine squared equals 1? Well, let's do sine squared t. Sine squared t plus cosine squared t equals 1. Now, we want to write tangent in terms of sine. Okay, so what we need to do here is, right now, tangent, do you see our function here? Tangent is in terms of sine and cosine. So the numerator is fine. We need to figure out how to write cosine in terms of sine too, so that this entire tangent function can be in terms of sine. That's where this equation comes into play. Do you see that we can write cosine in terms of sine? If we subtract sine squared t from both sides, we get cosine squared t equals 1 minus sine squared t. Do you see that now we have cosine in terms of sine? So now, let's go try to rewrite tangent t. Tangent is sine, the tangent of t is equal to the sine of t over the cosine of t. And now that we know that the cosine of t, one more thing I did. Do you see that this is cosine squared t? We need to figure out what cosine t is. So if we take the square root of both sides, we get cosine t equals plus or minus square root 1 minus sine squared t. So now that we have solved for the cosine of t, that can be our denominator. Plus or minus square root 1 minus sine squared t. Now, you'll see that we've got a radical in our denominator. We obviously can't keep that, so we have to rationalize our denominator. So we need to multiply by plus or minus square root 1 minus sine squared t on both the numerator and denominator. And so you end up with tangent t equals sine t times square root 1 minus sine squared t over 1 minus sine squared t. Oh, and then this is plus or minus. Now, we need to figure out whether or not it is actually plus or minus. Which one? The way we do that is, because t is in quadrant 4, let's think about it. In quadrant 4, our signs are going to be positive, negative. And remember, tangent is y over x. So tangent is going to be negative over positive. Oops. So what is negative over positive? Negative over positive is negative. So your answer is actually going to be negative sine t square root 1 minus sine squared t over 1 minus sine squared t. And that would be, do you see that now we have written the tangent of t in terms of sine t, that sine is the only trig function now written in this expression, but this represents the tangent of t. It's sine over cosine, and cosine is in our denominator. And you may want to ask me about this in class because I know that was kind of a longer problem. Okay, and last problem we're going to do for these videos is this one. It says, using the identities, if cosine of t is 3/5 and t is in quadrant 4, find all trig functions. So let's go ahead and draw our unit circle and see if we can figure out what's going on here. Okay, we know t is in quadrant 4, so let's go ahead and draw that. Whoops, I'm going to do that in blue. Okay, so we can draw a reference triangle. Now, we don't know what t is, but we do know that cosine of t is 3/5. So wouldn't you say that cosine of t, the x value, is 3/5? And wouldn't you say that we don't know what the y value is, do we? So we're going to call that x. Or why don't we call that y, just to not be confusing. We do know that the radius is 1. So if we have 3 sides of a right triangle, can we find the third side? Of course we can. A squared plus b squared equals c squared. So we say 3/5 squared plus y squared equals 1 squared. So that's going to be 9/25 plus y squared equals 1. So we say y squared equals 25 over 25 minus 9 over 25, where 25 over 25 just is 1 written with a common denominator. So we get y squared equals 16 over 25. So y equals plus or minus 4/5. Okay, so now we have y equals plus or minus 4/5. The way we determine whether y is plus or minus is we look on our unit circle. The y value here is actually negative. So in this case, y will be negative 4/5. So let's fill in 4/5 here, negative 4/5. Now what we need to do is find the 6 trig functions. So let's find sine t, cosine t, tangent t, cosecant t, secant t, and cotangent t. Okay, so sine, remember, is your y value, negative 4/5. Cosine is your x value, 3/5. Tangent is y over x, so negative 4/5 divided by 3/5, which is negative 4/5 times 5 over 3, which is negative 4/3. Okay, and remember, cosecant is the reciprocal of sine, so that's going to be negative 5/4. Secant is the reciprocal of cosine, which is 5/3. And cotangent is the reciprocal of tangent, which is negative 3/4. And those are our 6 trig functions. You'll notice that the sine and the cosecant are negative because the y value is negative. Cosine and secant are positive because the x value is positive. Tangent and cotangent are both negative, because they are the ratio of x to y. And whenever you have a positive negative ratio, that makes for a negative number. One thing I'll also have you notice, and this comes up in on test a lot, do you see how this never asks what the angle at what t is? Make sure you pay attention to that. In a case like this, you can go and try to figure out what t is, but do you see that that's an exercise in futility? It doesn't matter. Who cares what t is? All you're asked for are the trig functions, and you can find those 6 trig functions without ever finding t. So just be aware of that and try not to create more work for yourself than you need. And that is it, the end of section 5.2.